What is an overlay network? From Cohesive Networks. First, a quick introduction to cohesive networks. We have a family of security and connectivity solutions called VNS3. They help you protect your cloud-based systems and applications. We have over 2,000 customers in 22 countries in all industry verticals and sectors. Our product, VNS3, virtualizes 6 network functions. VNS3 acts as a virtual router, switch, firewall, VPN concentrator, protocol redistributor, and extensible NFV. So what is an overlay? In this diagram, this is a simple topology with a data center based in Chicago and a remote office in London. Both locations use the public internet to connect to their cloud resources. The cloud data center has virtual instances or virtual machines. Each VM runs in a physical host or hypervisor connected to a switch. Each switch is connected to a firewall, then to a router, and this edge router provides the cloud's connectivity to the internet. All 3 sites have connected to the internet by switches, firewalls, and routers. All 3 topologies are made up of a combination of physical and virtual devices, multiple layers, and different types of virtualization. We call this setup the native layer. Now if you add in VNS3, that virtual firewall, router, switch, and all of that, the same native topology is present, but with an additional VNS3 controller on top. VNS3 is a software-only virtual appliance running within the host hypervisor. It creates an overlay network in your cloud, separating network identity from physical network location. The VNS3 controller acts as a virtual switch to provide overlay connectivity to each of the compute hosts and switch traffic between them. The compute hosts are configured to talk to VNS3 controller as a client server, and they see the VNS3 controller as the next logical hop. VNS3 is configured with subnets, giving it a range of IP addresses available for static allocation to the client servers. This allows them to join an overlay network. The 2 red lines in this example are IPsec tunnels for VNS3 controller to a remote firewall. Both London and Chicago have 2 different endpoints. Behind each endpoint is a remote subnet. In this example, when the traffic still travels on the native network on the same native devices. Logically, VNS3 is layered over the top of the devices to provide an overlay network function. A VNS3 user can select the IP address for each client server in the public cloud, and these overlay IPs are accessible from both London and Chicago. Note that the native devices are still present in the topology and still provide native physical and virtual connections. The overlay is layered over the top of the native and still depends on the native. So what if you need high availability? This diagram shows the same network topology with additional VNS3 high availability. When you have 2 peered VNS3 controllers, they exchange the given topology's routing information and share client-server credentials and connectivity details. Any connected client servers can connect to either manager. In turn, both controllers will start to be able to access the clients, no matter which controller the client server is connected to at the time. Similarly, all IPsec connections to either manager are accessible via both controllers and via client servers. VNS3 high availability solutions have automatic failover features, and there's no user intervention required. Note here that the 2 peered VNS3 controllers provide overlay network failover high availability, but not technically IPsec failover. The endpoint IPsec devices should have its own high availability features. This diagram shows IPsec active tunnels from each remote site, so the solid red line. This dashed red line is a passive tunnel, which are up and ready to take over if the active function needs to make a hot standby. So in the instance of a VNS3 controller failure, here with the big red X, say this is the primary controller. If it's unavailable for any reason on the client server can automatically attempt to connect to the other controllers in the topology. This shows the failure of controller 1, and then controller 2 takes over as the primary role and identity. Peered controllers provide overlay network failover, high availability, but not IPsec failover again. Hopefully your IPsec endpoint will create the peer list and should have its own IPsec failover. So in summary, VNS3 acts as a virtual router, switch, firewall, protocol redistributor, VPN concentrator, and extensible NFV. For further information, please check our support documentation. VNS3 is available in most public clouds, private clouds, and virtual infrastructure. VNS3 does support most IPsec-based data center endpoint solutions. Make sure to get in touch with any questions. You can email us at sales@cohesive.net or chicago@cohesive.net, or if you're having trouble, support@cohesive.net.